Sorry about that. I somehow missed and ended my video, so this is a two-part video because I messed up. So if I check my point 4, 2, if y is 2, 2 plus 1 is 3, is less than negative 4, because we're making x negative, so that point works. Right? And then if I plug in 2 here, 2 is greater than 1, so that point works. So this region works. Sorry, I colored this in, but that's not really supposed to be colored in because it didn't work. So then the solution is this little area here, and it keeps extending all the way out. This is the solution. It includes all the values on this line, but this line is dashed. Those points are not included. Okay, so let's look at number 2. The first equation, x is greater than negative 2. So we're going to go to x is negative 2. There is no y, which means there's no y-intercept. Okay, and that means we have a line going straight up and down through negative 2. And x is all numbers less or greater than negative 2, so that would be all the numbers over here. So that one we can kind of shade already and kind of think about. The second equation, if you see, I divide everything by 2 because we get y by itself. So y is greater than or equal to 3 over 2 plus 3. So we're going to start at positive 3. We're going to go up 3 and over 2, down 3 and over 2. And we've got this line. It says equal to, so we're going to make a solid line. So now we can check points in each region. If I try 0, 0, because that's in the shaded region, we're just trying to figure out if it's up here or down here. 0 is greater than negative 2. That is true. And 0 is greater than 3 times 0 plus 6. That is not true. So then we're going to try, we said this region doesn't work, so let's try this region. Let's go to negative 1, 4. So if x is negative 1 is greater than negative 2, so that works. And then over here, 2 times y is 8, because y is 4. 3 times negative 1 is negative 3 plus 6. 8 is greater than 3 is true. So we're looking in this region right here, and that's the solution. There are some students that will say, well, is there a shorter way to do this? There kind of is. If you see a greater than, the general rule is a shade above the line. If it's slanted, think above and below. So greater than is above and less than is below. So we'll look at the next problem like that. So we'll start with this. Start at negative 3. The slope is 2, so we're going to go up 2 over 1. This line should be solid because it says equal to. And then we'll graph this, and it says y is less than. So if I think of this as a slanted line and I want to push the line down, the less than values are down here. And then I go to the second part and I start at positive 2, and I'm going to go down 1 and over 2. And draw that line. It's solid because it says equal to, and this one says less than as well. So if I think of this line and I think pushing down, less would be all of this down here, and the solution is where they intersect would be this section here. So now you're going to do these 6 problems on this page using the same idea, and then together, sorry, wrong page, we're going to do the I do, which is a word problem on the next page. So the drama club is selling tickets to its play. An adult ticket costs $15. A student ticket costs $11. The auditorium will seat 300 ticket holders, and they want to make $3,630 in ticket sales. And there's a typo here. We shouldn't write 4 inequalities. We only need to write 2. So let's first write about the number of tickets. So adult tickets plus student tickets should be less than or equal to 300. They can't sell more than 300 tickets. They could sell 300, so either equal to or less. Then we gotta look at the cost. So an adult ticket costs $15 and a student costs $11. And they wanna make at least, so that means more than or equal to $3,630. So now we're gonna graph this. And because these are in standard form, I'm gonna do the X and Y intercepts. So A would be 300. Which is for adult ticket, and then if we cover up the A, the S would also be 300. So on the students, we're at 300. If we connect those 2 points, and we want it to be less than that, and we shade the whole area underneath it, those are all the possibilities for possible numbers of tickets sold. Now we gotta look at the cost. So if we do the same thing, we cover up the S, we get A. A comes out to be 242. So that's somewhere right in here. And if we do the same thing with S, we cover up the A. S comes out to be 330. So that would be up in here. And if we connect those together, and this one's supposed to be greater than, so that's all up here. The solution is this region right in here. So anything in this region is going to work. And then it says to give 3 different combinations of tickets to satisfy this. So I was going, okay, let's go over 200, so 250 up to 50, 250, 50. That makes 300 tickets. And if I calculate this out already, that gives them a profit of $4,300, which is more than they wanted, so we're good. Then I said, okay, let's go over here, and let's say we did 200 tickets, adult tickets. That would mean 100 students. And if I calculate that out, that gives me a profit of $4,100. So that's on this edge, and then we're at this edge. And then if we want to find another value, let's go in between, and let's go with 225, and then 75. And oops, I didn't calculate that one out, but you can calculate what that would be. So 225 times 15 plus 75 times 11, and that will tell you your profit, which will be within the range. So that's how you're going to do that problem. You get to do the you-do, which is a very similar problem. So write the inequations and do the same set of problems.